All right, this is a video for the 8.1, 8.2 practice for Friday. So let's check out number one. Number one says simplify completely, and it is a radical, it's a square root. And so what we're going to do is we're going to break down the radicand into its prime factors. And so if you use a factor tree, factor ladder for this, that's great. If you can do it in your head, that is fine too. So 54 is really 3 times 3 times 3 times 2, and of course x to the fifth is just x times itself 5 times. So there's 5 of them. And then as you know, what we're going to do is we're going to go through and look for pairs of like factors. And so there's a pair of 3's, there's a pair of x's, there is another pair of x's. And so what we're going to do now is bring those out. So remember, a pair of 3's inside the radical comes out as a single 3, and then a pair of x's would come out as a single x. The other pair of x's would come out as another single x. So I've dealt with these 3's. There's the first x, there's the second x. And then, of course, there's several factors in there that did not have anything to pair with. So the 3 times the 2 multiplies to be a 6, and this x is still left over inside the radical. So as I multiply the two x's together on the outside, the final simplification here would be 3x squared times the square root of 6x. Number 2 says a basketball court has a sideline that is 86 feet long and a baseline that is 58 feet long. If a player runs along a diagonal of the basketball court, how many feet does the player run? Find your answer to the nearest tenth of a foot. So I'm going to just draw a quick picture of this. Basketball court, of course, is a rectangle, and we are told that it is 86 feet long and it is 58 feet wide at the baseline. And so if a player started in one corner and ran to an opposite corner like such, that would define a diagonal. We want to know how far they would run. So since a basketball court is a rectangle, that means all of the angles are right angles. So importantly for this, that angle right there would be a right angle. And I'm going to label that red line segment with a D for diagonal. And of course, one of the rules that applies to a right triangle is the Pythagorean theorem. That's the one we want to use here. So remember, the Pythagorean theorem is leg squared plus leg squared is equal to hypotenuse squared. And in my triangle picture here, the 86 would be one of the legs, and the 58 would be another one of the legs, and the hypotenuse is the diagonal. I know that the hypotenuse is the diagonal because the hypotenuse is always across from the right angle, and the diagonal is across from the right angle here. Okay, so we're going to use our calculators here to evaluate this. It does say round to the nearest tenth of a foot. So 86 squared is 7,396. 58 squared is 3,364. That's equal to D squared still. If I add those up, I end up with 10,760 is equal to D squared. Of course, we're looking for the length of the diagonal, so I need to get rid of the squared. So what I'll do now is square root both sides, and the square root of that number, 10,760, is, round to the nearest tenth, would be 103.7 feet for the length of the diagonal. All right, number 3 says simplify completely, and this is sort of like number 1, square root of 180 x to the 10th. In order to do this, I need to break down my radicand into its prime factors. So 180 would be 2 times 2 times 3 times 3 times 5, I think, right? Yeah. And then x to the 10th would just be x times itself 10 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2, 4, 6, 8, 10. Okay, we're good. All right, so again, I'm looking for pairs of like factors. There's a pair of 2's. There, right there, is a pair of 3's. And then, of course, I've got a bunch of pairs of x's, like so. In fact, all of the x's have another x to pair with. So the 2's come out as a single 2. The 3's come out as a single 3. And then all the x's. There's a pair of x's coming out as a single x, another pair coming out as a single x, so on and so forth. And you're going to find, of course, that there are 5 pairs of x's. And so that means I'm going to have x times itself 5 times on the outside. There's only a single factor that didn't have anything to pair with, and of course, that's the 5 right there. And so that's left over inside the radical. To simplify this all the way through, 2 times 3, of course, is 6. It'd be 6x to the 5th times the square root of 5. Okay, number 4 says rationalize and simplify. So if you remember from our classes this week, we are not supposed to have or not supposed to leave a radical in the denominator, and of course right now there is one. So in order to get rid of this square root of 11, what I need to do is I need to multiply both the bottom and the top of the fraction, both the numerator and the denominator, by square root of 11. So 7 times the square root of 11 is just 7 times the square root of 11. And then in the denominator, square root of 11 times the square root of 11 would be square root of 121, because 11 times 11 is 121. And then, of course, we know from the perfect squares chart that we saw earlier that 121 is a perfect square. Square root of 121 is 11. And so this would be it. What we've done now is we've rationalized that fraction. There are no more radicals in the denominator, and we're done. Now finally, number 5, we've done a couple of these this week. Thought this would be another opportunity to do another one of these. Keep in mind that whenever you've got the square root of a fraction like this, before you go splitting up any square roots, your best bet is going to be to try to simplify the fraction inside the radical, the radicand there. So what I notice is that I've got an x in the top. I've got x to the 4th, of course, and then I also have an x in the denominator as well as a factor. And so then I can cancel. So what I'm going to do is I'm going to cancel this x with one of those, leaving me with x to the 3rd. So I'd probably start off by writing this as the square root of 27x to the 3rd over 16. 27x to the 3rd over 16. So at this stage, what I can do is then split up my radicals. So it's going to be square root of 27x to the 3rd over the square root of 16. The square root of 16, of course, is 4. And we're going to have to break the numerator down into its prime factors. So 27 is 3 times 3 times 3. X cubed is just x times itself 3 times. So looking for pairs of like factors, I've got a pair of 3s. I have one leftover 3. I've got a pair of x's and a leftover x also. So to finish this out, the 2 3's come out as a single 3. The 2 x's come out as a single x. Inside the radical, there's a 3 left over, and there's an x left over. The denominator is still 4. That would be our final simplification for number 5. All right, I hope this went well for you. You'll be working on your quiz here in a few minutes.